So here is the specific example of Ricatti's equation. Now how will you judge that it is a Ricatti's equation? If you have first order differential equation and along with that it contains some y square, then you can definitely judge that it is a Ricatti's equation. So now we write the standard form of Ricatti's equation, and the standard form of Ricatti's equation is dy by dx equals to p of x plus q of x y plus r of x into y square. So here you can relate it that p of x is -1 here, q of x is 0 here because there is no y term, and r of x here is, if we shift this to another place to right hand side, then it becomes +1. Right, now we start our assumption. Okay, y equals to y1 plus 1 by z. So y1 here is mentioned and that is +1, so 1 by z. So definitely dy by dx will become 1 has derivative 0, so that becomes -1 by z square dz by dx. And now I am replacing this dy by dx and y in this given differential equation. So dy by dx minus y square minus 1, I am replacing this. So dy by dx is -1 by z square dz by dx and minus y square. Y is 1 plus 1 by z whole square equals to -1. Right, 1 by z square dz by dx, and I am going to open this whole square, and that is 1 plus 1 by z square plus 2 into 1 by z. So 2 by z equals to -1. Now in the next step, -1 by z square dz by dx minus 1 by z square minus 2 by z equals to -1. So -1 and -1 are cancelled here, and again we are left with 1 by z square dz by dx minus 1 by z square minus 2 by z. So I want to get rid of this z square in the denominator, so I multiply it with minus z square, and this equation becomes minus z, and minus z square divided by minus z, that becomes +1, and that becomes -2 equals to 0. So if I arrange this in proper form, it's 2 plus 2z equals to -1. Now you can definitely see that this is a linear equation in z. So this is linear equation in z. From here you can select the p of x, right, and use the integrating factor method to solve this equation. So, and mu of x e to the power integral 2 into dx, so that becomes e to the power 2x. Now I am multiplying this integrating factor. This is, let's suppose it's equation 2, so I multiply this with equation number 2, dz by dx plus 2 into e to the power 2x into z equals to minus e to the power 2x. And in the next step I am multiplying this dx on both sides, so that becomes +2, and I am writing it along with the x terms into minus into dx. Now you can definitely see that this is the expanded type of derivative product rule, and it is the first term has derivative, and second as it is first has derivative, second as it is, so and also second has derivative first as it is, so you can identify the original function. Here it is the second original function and first has derivative, and its derivative is 2 into e to the power 2x dx. So here it is its derivative second function and original function as it is. So you can judge or check the original functions directly. So first function was basically I converted into the from the expanded form into the compact form, and that is, so now the original function is z and e to the power 2x, and here it is e minus e to the power 2x dx. In the next step I do the integration, minus e to the power 2x into dx. So this derivative and integral gets cancelled, and next step will be, I'm writing in this space, let me arrange this. Okay, I'm writing here. So that becomes z into e to the power 2x equals to integral e to the power 2x dx. So z e to the power 2x equals to e to the power 2x has integral minus e to the power 2x divided by 2 plus c, and z is minus e to the power 2x divided by 2 into e to the power 2x plus c divided by e to the power 2x. So it becomes minus e to the power 2x plus c plus 2 into c. If I take the LCM, 2 into e to the power 2x. So that is basically z, and I again transform this z to y. How I will transform this z to y? Because y equals to y1 plus 1 by z, and y1 here is 1 in this particular example. So if I shift this y minus 1 in 1 by z, then z is 1 over y minus 1, right? So if I replace in terms of y, then z becomes 1 over y minus 1 equals to minus e to the power 2x plus 2 into c divided by, if I take the reciprocal or cross multiply it, then y minus 1 becomes 2 into e to the power 2x minus 2x plus 2 into c, and y becomes 2 into e to the power 2x divided by minus e to the power 2x plus 2 into c plus 1. So that is the final answer. If we have the initial condition, then we can definitely find out the c. So that is Ricatti's equation. Very, very simple, and only it contains the one assumption, that is y equals to y1 plus 1 by z. I hope that you understand this method, and if you have any queries, you can ask me.